So hopefully you already wrote it down. Warm up. If a die is rolled and a card is drawn at the same time, what is the probability of rolling an odd number and drawing an even number card? So they're independent events. You got two independent events. One does not affect the other. You roll a die. So how many sides does the die have? Or how many numbers? Six. Half of them is even, half of them is odd. So you could just say half, no? Or you could do what? 3 out of 6? And then how many of the cards are even numbered? So, well, you don't have to care about that's a 1, even if you think it's a 1 or whatever. It's not even even number card. So we're gonna say 2, 4, 6, 8, 10. Are those numbers J, the Jack, Q and King? They're not numbers, they're letters, no? So 1, 2, 5 times what? How many total is it? 1, 2, 3, 4, 5, and then 20. 20. 20 out of what? 52. Multiply that out. Well, it's 1/2. This is what? 1/2. This is divide that by what? 4. Divide this by 4. 5 over 13. And that's gonna give me 5 out of 26. And you can turn that into a percentage, no? If you wanted to, if that's what's on test, if it's as a percent. All right, moving on. Mutually exclusive, mutually inclusive events. Mutually exclusive events first. Mutually exclusive events is if A and B are mutually exclusive events. That's because it's discriminatory. It only this and then that. They cannot mix. Event A and event B cannot happen at the same time. And the formula is P of A or B is equal to P of A plus P of B. All right. So the best way to do this, if I can remember, is by doing a little experiment. This or that. Do I have it written down or no? I think I don't. There's no overlap. Man, I should have wrote it down. I forget. Okay, here's an example. I do have an example. Okay, I wrote it down. Example. If one student from this class is chosen at random, what is the probability that that student is 17 or 18 years old? So this is A is 17 or 18 is B. So if you want to go back over here to probability of 17 or 18, you cannot be 17 and 18 at the same time, can you? You can't be 17 and 18 at the same time. You either, either you're 17 or you're 18, and you cannot be both at the same time. Okay, so let's do that. All right, so that's it. I'm not going to count anybody else that walks in after right now. It's going to be how many people are right now in here? Okay, there's a total 23 students right now in the class. So that's what I'm going to do is out of 23, yeah. Raise your hand if you're 17 years old. Up high if you're 17. If you're 17, a little bit up high again. One more time. 17? ¿Tienes 17? Okay, right now, let's go. So I want to come, raise up your hand. 17, let's go, 17. Five? Put your head down. 18. Up high a little. 18. One. Are you guys not trying to participate? It's not gonna work if you don't participate. What? Are you 19? Anybody in here 19?
We're juniors, not seniors.
So you'll be 16?
We'll be 17. We're 16 right now.
You're 16 right now? Oh, let me see real quick. 16. Raise your hand up high. Okay, that's a lot. All right. Okay, so 17 or 18, what's the probability of 17 or 18? What's that? Add them up. Is it over 23? What is it? 6 over 23? So you can change that to a percent, and you get a percentage of that. Oh, you can turn it into a percent. Okay, now let's go to mutually inclusive events. Mutually inclusive event probability. If you do, I'll show you one. I'll show you this one how to change the percentage. That's if it is. If A and B are mutually inclusive events, is that because you could be both. You could be in both worlds. Event A and event B can happen at the same time. So this is the formula for it. It is kind of like the same as the other one, except you have to subtract the double count. So P of A or B is equal to P of A plus P of B, but you have to subtract what is both A and B, because that's a double count. So that's the formula here. And there's an overlap. All right, so here's an example. If one student from this class is chosen at random, what is the probability that the student is 16 or a girl? So definitely you could be 16 and a girl, both 16 and a girl. And I'll bet for sure there's somebody already said, I think you're a girl and you're 16. So we're gonna go probability of 16 or girl and I think that will hopefully there will be a double count. Yeah, like I just said, there will be a double count that you have to subtract. Probability of 16 is out of 23. Everything out of 23. "16 years old." One more time. Raise up high your arm so I can count correctly. 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13. Raise your hand if you're a girl. No, you don't have to raise your hand. How many girls are there here? 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13. 13. 13, what? Okay. 16 and a girl. Raise up, that one you have to raise up your hand. 16, you're 16 years old. Raise up high a little bit. 1, 2, 3, 4, 5. You're raising up your hand? You're 16 and girl? You go like this. Hold on. Raise up high again one more time. 1, 2, 3, 4, 5, 6, 7, 8. That's it, 8. All right, 8. So that's a double count that you have to subtract. So just they're in both. That's why you got to subtract that part. 26 minus 8. 18 over 23. Whatever that percent. Okay, so you guys got a calculator. How do you change this to a percent? So you're gonna go 18 divided by 23. So I'm getting 0.78. If I'm gonna round to the nearest 100th, or no, the nearest whole number. So if I just do 78 and not the rest of it, because you're not rounding, was 26. But say you went around, we've done this before already. What do we do? Move it to the right, 1, 2. So it's gonna be 78%. And that's depending on what it's rounded to. That's it. That's pretty much the lesson. Let's just do one more. I think there's more. Yeah, let's do this. Let's finish this. Complete this two-way table and then answer the following questions. Yeah, this data is from the. Okay, let me actually. Looking at the data here and look at all this stuff. You guys are reading this. I'll give you extra credit for anybody who knows where this data comes from, just by looking at everything. Where does this data come from? That Titanic is correct. Yes, is that Titanic. So, what, 100 years ago, there's a ship that sank. It was called the Titanic. And there was first class passengers, there was second, third class passengers, and this is just the passengers. And there was also the workers. And we have, this is not even part of the data there, but there's a lot of people that died that were workers also. So in the first class passengers, (201) survived out of a total of 324 first class passengers. How many did not survive? (123). So we'll fill that out. 123. Second class passengers. How many survived? If we know how many did not survive, we have a total 118. Third class passengers total. That's, how many were there total, third class? 600 and what? What? Do I not know how to count? That is 600 something. 709. Total passengers then? 1317, is it? Is that one right? All right. So now let's answer some questions. If one of the passengers is randomly selected, what is the probability that this passenger was in first class or second class? First class or second class? So you were either in first class or second class. Yeah. You could not have been in both. So, yeah, let's go. So this is mutually exclusive. So how many were in first class? 324. 324 out of the total. So this is out of the total number of passengers. So this is out of a total. And how many were in second class? 284. So again, add them up. It's over a common denominator. And then you could change it to percent if that's what it's asking on the test. Last one here, I think, for this. If one of the passengers is randomly selected, what is the probability that this passenger was in third class or survived? Okay, so probability third class or survived. I don't know. Yeah, I'm just gonna go with S for survived, not writing too much. All right. So could you have been in both? And I think you could. Let's plus and then minus. In third class, so it's out of 1317. How many total were in third class? 709. Survived, still 1317 here. How many survived? No. It's a total survived, no? How many total survived? Look, total of this and then total of that. How many total did you say 500? Is that what you said? You said. Huh?
500. Total of survived is 500.
Yes, 500. Yes, that's what goes here. 1317. Now here is the double count. How many were in third class and survived? How many were in third class and survived? Third class and survived 181. That's the double count. So add 709 to 500, get that, subtract 181 over 1317, and that is going to be and you can change that to a percent. And that is all for today.